Okay, so we're going to be starting alternating series, which is section 8.6 here. I'm actually going to try something different in this video here. I'm actually wearing a glove as I write because the touchscreen, if my fingers would hit something at the bottom of the screen or my hand, it would go to the desktop or other things like that. So I'm hoping by wearing a glove that will prevent that from occurring. So alternating series is the thing that I think most people struggle with in this section because it's a very different kind of test, and it's a very different kind of series. So before we even talk about the test, let's make sure we understand what an alternating series is. So an alternating series has each term. This might not be the best way to explain it, but we'll write an example down. Flip its sign. So let's just look at an example of an alternating series. This is an example of an alternating series. -1 to the k power times 1 over k. Because if you do this for k equals 1 to infinity, you would have -1 over 1 plus, and then I'd have -1 squared, so it'd be plus 1 over 2. Then we'd do 3, which would be negative, so I'd have -1 to the third, which is a negative, so -1/3. Then for the fourth, -1 to the k would be positive, so I'd have plus 1/4, and then so on, -1/5, plus 1/6, so on and so on. So this is an alternating series. And as we can see here, the idea here is that I start off with a negative, and you don't have to start off with a negative, you could easily start off with a plus, but then the next term is positive, next term is negative, next term is positive, negative, and then positive. So that's what makes this an alternating series. Now, one obvious indication for an alternating series is going to be that you have -1 to the k. But there are other ways to write that down that sometimes trip people up here. So let's write some other examples here with trig functions. There are other ways to generate -1 to the k. I mean, obviously -1 to the k works. As a side note, you also might see -1 to like the k plus 1. All that's going to do is change which term is, whether it's an even or odd number being positive or negative. That's still clearly alternating. But one that sometimes throws people off here is the cosine of pi k. Because if we think about this, if we just do k equals 0, 1, 2, ... the cosine of pi k, well, I'll just go ahead and do this. K equals 0, 1, 2, 3, 4, 5, and I'll go ahead and write these down below here. So I'd have cosine of 0, which is 1. Then you'd have cosine of pi, which is -1, cosine of 2 pi, which is positive 1, cosine of 3 pi, -1, cosine of 4 pi, which is positive 1, and then of course -1, and we could go on, and that is alternating there. So that's a key term here, is that cosine of pi over k gives me, and I'll just write it down here, cosine of pi k is equal to -1 to the k power. So that's something very important you want to remember, especially when it comes to alternating series. You can do one with the sine function. It's not as commonly used, but if you have sine of pi over 2 times k, this is equal to -1 to the k for k equals 1, 2, 3, on and on. You can't start at 0, because if you start at 0, you get the sine of 0, which is 0, which technically you could, it's just the first term would be nothing then. So sine of pi over 2k also gives you a -1 to the k, so it's also alternating. Alright, so hopefully you get a clear idea of what it means to be alternating here. Let's just look at two more examples here before we go into the test here. K equals 1 to infinity of 1 over k squared. This is going to be 1 over 1 plus 1 over 4 plus 1 over 9. Clearly not alternating. And then if we do sum from k equals 1 to infinity cosine of pi k times k factorial over e to the k, this is clearly alternating as well, because remember cosine of pi k is equal to -1 to the k, so this gives me alternating. So basically, you know it's alternating if you have a -1 to the k, or k plus 1, or whatever. I mean, you can have it, as long as you have a -1 to some k power, it's alternating. Alright. So next thing is to actually talk about the test. But before we talk about the test, I think I'm going to do something different than what I've done in the past here. Let me just kind of say here, there are many types of convergence. We have just been saying a series converges. But there's often much more you can say, and when I say there's many types of convergence, let me just write down some of these. Now we're not going to need all of these here. We're not going to talk about all of these, but there is uniform convergence, there is pointwise convergence, there is conditional convergence, there is absolute convergence, there's things that are called L1, L2, L3 convergence. Then there's little L1, little L2, little L3 convergence. And there's even more that I could list down here. But the point is there's lots of types of convergence that you can talk about. Now in this course, we are going to talk only about two. So we're only going to talk about conditional and absolute convergence. So first off, conditional and absolute convergence only apply to alternating series. So you really want to think about when you see an alternating series, this is a completely separate thing from all the other tests. So if you see an alternating series, ignore all of our other tests. Well, I should be careful. Do I want to say ignore all of our other tests? Well, I'll put it here, initially ignore all of our other tests. We will use some of the other tests eventually, but initially you want to ignore all of them. Alright, so now we have to talk about how do we determine whether an alternating series converges. Now, the thing that messes people up here is that they try and use the test for alternating series for other series. This is only for alternating series. So the test is that if the sum of a sub k is an alternating series, and the limit as k goes to infinity of a sub k equals 0, then the series converges. Okay, so again, this is only for alternating series. So only use for alternating series. If you use it any other time, I'll probably take off most of the points, because this is only used for an alternating series. And again, how can we tell alternating series? -1 to the k. That's alternating series. Alright, so then what do we do here? Well, I can determine whether it's an alternating series or not. I have this test. Well, then if an alternating series converges, we need to determine if it is absolute or conditional. So once we know an alternating series converges, this is where we have to then determine whether it's an absolute or conditional convergence. Now, the way you do that is you look at the absolute value of this and determine if this series converges using tests from sections, what would it be, 8.3 to 8.5. So Then you're going to look at the absolute value of the series and determine if it converges using tests from 8.3 to 8.5. But when you do the absolute value, this absolute value really just gets rid of the negative 1 to the k. Then if this series, if the absolute value converges, the series converges absolutely. If this series diverges, then series converges conditionally. Now I know I've written a lot of things here and we haven't done very many examples. I was just trying to emphasize the tests. In the next couple videos here we're going to go through some examples of how to do these kinds of problems.